Hello everyone, I am Parag Karanjekar, team leader of Team 7. Me along with my teammates Akshat Lade, Bhoumik Mhatre, Dhanshri Gawale and Sourodeep Datta. We have worked on this DIY project which is color temperature based indoor lighting system. We worked on this project because the modern LED and other artificial light sources tend to have a constant intensity and frequency, and thus alter our sleeping cycle along with reducing our efficiency while we are awake. The proposed lighting device will regulate its own color based on the time of the day and provide optimal frequency and intensity of light throughout the day, maximizing our productivity and reducing the stress. It can also help people with sleep disorders, elderly people, and those with SAD. To determine the best color temperature and wavelength for our circadian rhythm, we compiled data from various online available research papers. Components used in this project are 12-volt RGB LED strip, Node MCU Wi-Fi development board, I2C OLED display, OLED display connector, 4x3 matrix keypad, 3 TIP120 transistors, 3 2.5 kilo ohm resistors, 12 volt 2 ampere DC power adapter, jumper wires, and a breadboard. First of all, the Node MCU is connected on the breadboard, and then I have connected the keypad which uses 7 pins to give input to the Node MCU. The pins where keypad is connected are S3, S2, D0, D3, D4, D8 and RX pins. S2 and S3 pins are actually used for SD card, but they work just fine with the input that keypad is giving. Then I've connected the display that uses 4 pins to connect to the Node MCU. The ground and VCC are connected to ground of Node MCU and 3.3 volt output of Node MCU. The serial clock and serial data pins are connected to D1 and D2 of Node MCU, which are respectively serial clock and serial data pins of the Node MCU. Then the D5, D6 and D7 pins are connected to the RGB output respectively. Those outputs doesn't go to the LEDs directly. They first go to the base terminal of the transistor, which is connected by a 2.5 kilo ohm resistance. The collector pin of the transistor is connected to the RGB LEDs, and the emitter pin is connected to the common ground from each of the three transistors. Then the DC power source is also connected directly to the LEDs, as well as the negative terminal of DC power source is connected to the common ground, and the ground pin of node MC is also connected to the common ground from the DC power source. Now I will be demonstrating how the light works. First of all, I have set up a serial monitor with baud rate at 115200, which is used to display the serial monitor of Node MCU. On the second screen, you can see the user interface. And on the third screen, you can see the color of light. Now I'll be resetting the Node MCU. As you can see, when the Node MCU has restarted, it has displayed connecting to Wi-Fi on the serial monitor, as well as it has printed the IP address. Now it is trying to receive data from APIs, and now it has received the data from APIs. So on the serial monitor, it is displaying the wavelength as well as the RGB 8-bit output. On the display, you can see that it is displaying a current mode to be auto, and it is also displaying the mode interface. On pressing 1, we can select auto mode, which is already selected. On pressing 4, we can select the manual mode, where user needs to give the time input. On pressing 7, we can select the sleep mode, and on pressing star, we can select the work mode. Now I will be changing the mode to sleep mode. Now I will change to sleep mode. On the serial monitor, you can see to a fixed value, that is 255, 112, and 0. And the light color is changed, as well as on the display the current mode is showing to be sleep. From here we can change the to the next mode. I will be shifting to work mode. In the work mode, now it has again changed the 8-bit output to 255, 244, and 248 for RGB respectively. For work mode, the light is quite bright, as well as cold tone, because it helps us in concentrating and focusing more on the work. Now I'll be showing you how the interface for manual input is. I'll be selecting the manual mode. It is asking me to enter the time. I've entered the time. Now since I have entered the time, it has displayed a message of time set, as well as it has shifted the message to current mode manual, because manual mode has been selected. From here we can now change to some other mode as well. I will be selecting work mode. Now it has shifted to work mode. Now I'll be entering some other value of time. Now the other time has been entered, so the color of light has changed, as well as on the serial monitor the wavelength of light has also changed. Now let me show you how the light looks after the sunset. Now, I will be entering some value in of time in manual mode, that is after the sunset. 7 p.m. is after the sunset. As you can see, the light has changed to dim red, which is preferable for us during the night time. Now I will be trying to enter some invalid input like a time above 24 hours into the manual mode to show how it works in that case. I'm entering the time 9999. It has shown that it is an invalid input, and it is asking for some other input. In case of auto mode, when the Wi-Fi is not available, the system automatically switches to a default light and shows the mode interface display, so that user can choose some other mode when Wi-Fi is not available for the auto mode. This is a time lapse of the varying light during the daytime. Was the sunrise, sunset, and current time data from API in auto mode, or the current time in manual mode from the user is taken? A graph of wavelength versus time is plotted for the whole day. And according to those wavelengths, 8-bit RGB output is determined. Once midnight is reached, data is downloaded again in auto mode, and in manual mode it is not required. This was our project of color temperature based indoor lighting from Team 7. Thank you.